This is a light emitting diode. The package they come in states that the voltage is 1.8 volts to 2 volts to make this thing work. Now we only have one battery or two batteries, and that's going to be 1.5 volts or 3 volts, which is not the voltage that we need. Let's see what happens. Notice that there's a long electrode on the light emitting diode, and that is the positive electrode. I put the long electrode into the positive side of one of the batteries. And now I'll attach the other electrode to the negative side using the alligator clamps. So now that I've connected it, it doesn't look like much is going on. Let's get a closer look. Notice the alligator clip there is not touching the positive lead on the battery, so I didn't short it out. Is that thing really on? Let's turn out the lights. Well, we do have a very slight glow coming out of that light emitting diode. Let's measure the voltage. I have the voltmeter connected in parallel across the LED, and I'm getting about just under 1.6 volts. And that's the voltage produced by one battery. Let's measure the current. Now, just again a warning, make sure you disconnect the meter before you switch it over to amps. I have mine set on the 400 milliamp scale. And then I'm going to put a break in the circuit so I can insert the meter in series. So you can see that the current's going to come out of the positive end of the battery through the LED into the meter and then complete the circuit. Let's see what we get. At the 400 milliamp scale, I'm getting 0 milliamps. I'm going to the 40 milliamp scale. Boy, that's barely nothing, 0.01 milliamps. So what this means is we are at the threshold of this LED turning on. And it did say on the package 1.8 volts, and we're just below 1.6. So anything below that 1.8, you get much below that, it's just not going to really light up. So what can I do if I want to reduce the voltage below what I have for one battery? I've hooked up two identical resistors and put them in series. That means half the voltage will be lost across the first resistor, half the voltage will be lost across the second. I'll check that with the meter. Yep, there we have it, half the voltage. Now I've connected the LED across parallel to that same resistor. I have half the voltage now, less than 0.8 volts, and it's not lighting up. And now I've put a break in the circuit and connected it to the ammeter, and we have no current here. Even if I go to the microamp scale, I'm getting nothing. Okay, I've put the two batteries in series now, and we're ready to try some larger voltages. But I don't want to go straight up to 3 volts. So what I've done now is I've got both batteries in series, and I've hooked up a 1000 ohm resistor, and you can tell by the colored bands. If you don't know how to read them, we'll talk about them another time. And I've got the LED plugged in, and I'm ready to plug it in over here. Well, look at that. Looks nice. That's pretty bright. Let's check the voltage. There we go, 1.8 volts. That's the operating voltage that it's designed to work at. And again, I've put a break in the circuit to go measure the current, and I get 1.38 milliamps. Now I've replaced the 1000 ohm resistor with a 220 ohm resistor, and that should increase the current and the voltage going through that LED. Let's see what it looks like when I plug this in. Yep, that's brighter for sure. And the voltage is up to 1.91, and the current 5.6 milliamps. So that's a big jump in current.